Hi, Calc, it's Mr. Szybisty, and today we're going to talk about 3.1, extremes. There are two different types of extremes. There are maximums, and this would be a maximum point right there, and there are also minimums. There are two different classifications of maximums and minimums. They are relative extremes or local extremes. That's where the graph hits a high point, but somewhere else on the graph it might be higher. This is called a relative maximum. An absolute maximum, though, is the absolute highest or absolute lowest place that the graph could be. For example, this is an absolute minimum. It is the absolute lowest place that you could be on the graph. We're going to talk about different ways that you can find relative maximums and minimums and also absolute maximums and minimums. But first, let's talk about relative. There are 4 steps for finding a relative extreme, either a relative maximum or a relative minimum. First, find the derivative and set it equal to 0. Second, solve for any critical values. There are 2 types of critical values, where the derivative is 0 or where the derivative is undefined. Like, for example, if there's a fraction and that denominator can't be 0. 3, plot the critical values on a number line and test the intervals. We'll see this when we do our first example. And then finally, we're going to do a little bit of analysis and we'll answer the question. Whatever the question's asking us, we'll give them the answer that they want. Let's take a look at the first example. Example 1. Find all relative minimums and maximums of the graph of f. Step 1, find the derivative. So f prime of x would be x cubed minus 4x. And set it equal to 0. So I'll factor this, x squared minus 4 equals 0. So I know x is equal to 0, 2, and negative 2. Now we're going to draw a number line, and we're going to put our critical points on there. 0, negative 2, and 2. Next step is testing the intervals. And here's how we test the intervals. Starting over here, I am going to pick a number that is less than negative 2. Like, for example, negative 3. And I'm going to substitute the negative 3 into the derivative. Negative 3 cubed minus 4 times negative 3. And my question is this number positive or negative? And it turns out that it is a negative number. And so I'm going to write a little negative up here. This means that on this interval right here, from negative 2 all the way to negative infinity, the derivative is always negative. It also means that the graph on that interval from negative infinity to negative 2, the graph is decreasing anywhere on that interval. Now we check this interval here between negative 2 and 0. Let's pick negative 1, and we'll substitute again the negative 1 back into the derivative. So I'll do negative 1 cubed minus 4 times negative 1 and evaluate that. And remember, the question is this number a positive or a negative? Turns out this one's positive. This means that from negative 2 to 0, the derivative is always going to be positive. Now I check on the next interval from 0 to 2. I'll pick 1 and substitute it in. 1 cubed minus 4 times 1. That happens to be a negative number. And when I pick a 3 and I substitute it into the derivative, that's positive. So now I have my sign chart. And what I'll end up doing is using this when I solve or when I do the analysis. Now let me show you how to do the analysis. When the derivative changes sign at points like it does at each of these, you know that negative 2, 0, and 2 will all be relative extremes. They could be a maximum or they could be a minimum. Here's how you justify what they are. For negative 2, the function was decreasing and then it started to increasing, which makes x equals negative 2 is a relative minimum. Because, and here's our justification, we have to be very specific when we do the justification. Because f changes from decreasing to increasing. At 0, we went from going up to going down. That makes 0 a relative maximum. Because f changes from increasing to decreasing at x equals 0. Let's add that in. So we say specifically where it's changing. So let me go up here and add in at x equals -2. It's very important that we're specific when we talk about these justifications. The AP exam will be very, very picky, and if you say something wrong, you might end up losing a point. Now, same thing with 2. That's going to be a relative minimum. X equals 2 is a relative minimum because, and I'm going to show you a different way to write it. This is another justification, and it's perfect, but it's different from talking about f. Here's what we say. X equals 2 is a relative minimum because f prime changes from negative to positive at x equals 2. And in class we're going to talk because f prime is changing from negative to positive. This is a chart of f prime, negative and positive. What the function is doing, as shown here in the pictures, relative maximum because f changes from increasing to decreasing. We'll talk about when you're supposed to use which words, but if you're talking about the function f, increasing and decreasing, talking about the derivative f prime, negative and positive. Now let's see absolute extremes on an interval. Page 118 in your book gives you some very, very good pictures that reveal why the candidate's test works. So I'd highly recommend that you go to your book and you read and look at page 118 to really get an understanding of why this test works. But what it says is that if you are asked for the highest possible place or the lowest possible place between two x values, candidates' tests say that they will either happen at a critical point or at an endpoint. We're going to test all of these and find their heights, and that's going to help us make a decision on which are the tallest. Let's take a look at an example. Example 2. Given f, find the absolute minimum and maximum value on the interval 0 to 5. So I already know from the candidate's test that the possibility is that the absolute min or the absolute max would occur at either 0 or 5. All I need to do is find the critical values, and that's going to be done using our formula. Take the derivative, set it equal to 0. So x equals 1 is my critical value. Now we're going to make a chart of the potential candidates and then their heights at those points. The candidates for this are 0, 1, or 5. And because we want to know their heights, we are going to take each of these and put them back into the original function and evaluate and see which one is the smallest and which one's the biggest. All right, if I plug in a 0, I get a 1. If I plug in a 1, I have 1 minus 2 plus 1, that's a 0. And if I plug in a 5, I get 25 minus 10 plus 1, which is 11. So x equals 1 is the absolute minimum, and x equals 5 is the absolute maximum. The minimum value is 0. That is the minimum value. It occurs at x equals 1. The maximum value is 11. This is the absolute value. The absolute value occurs at x equals 5. Be very, very careful about what the question is asking you. Here it asks you to find the minimum and find the maximum value, and so these are going to be your values. Sometimes they just want to know where they are, and in those instances you would give the x values. Now let's see if we're not on an interval, but we're talking about the entire domain. How can you find an absolute minimum or an absolute maximum? So what if I want to know the absolute maximum over the entire domain, or the absolute minimum? It can be very, very tricky to prove this because you'll have to get into limits and you'll have to understand behavior and what has to exist. What we'll see in this course are functions that abide by what we call the lonely critical value theorem. Now, unlike the MVT or the IVT, things that you can quote on the exam, you are not allowed to quote the lonely critical value theorem. It is not an actual theorem that is well known by all mathematicians, but it's the way that we sort of think about this so that we can understand. And here's what it says. If your function has one critical value, and that critical value is a relative extreme, it is guaranteed to be the absolute extreme as well. So, to recap, if you have one critical value, and you can show that that critical value is a relative extreme, you are guaranteed that it is an absolute extreme. Let's take a look at how we can actually go through and we can prove an absolute maximum for a function. All right, in example 3, we want to find the minimum value of y equals x to the fourth minus 8x plus 5. And notice when it says minimum value, it means absolute minimum. If we meant relative minimum, we would have said relative minimum in the problem. So if it doesn't say, if it just says minimum, we're talking about a global minimum or a absolute minimum. First step is to find critical value, so we take the derivative, y prime is equal to 4x cubed minus 8. We want to set that equal to 0, so we get x cubed is equal to 2, x equals the cube root of 2, and I'm going to make my number line. Cube root of 2 is here, and I'm going to take two numbers, one on either side. To the left of cube root of 2 is 0, and when I plug in a 0, I get a negative. To the right, I know cube root of 2 is between 1 and 2 somewhere, so I know 2 is greater than it. When I substitute in a 2, I end up getting positive. So I can say that x equals the cube root of 2 is a relative minimum, because I went from decreasing to increasing. It's a relative minimum because f prime changed from negative, now when I write that out, I don't want to use too much shorthand here, negative to positive at x equals cube root of 2. Now I can invoke the lonely critical value theorem. Because x equals cube root of 2 is the only critical value, and since it is a relative minimum, it is also the absolute minimum. And I'm all set. All right, ladies and gentlemen, next time in class we're going to talk about some of these. We're going to go through some problems where you'll find relative maxes, relative mins. You'll find absolute minimums and absolute maximums if I give you an interval, and also a few that use the lonely critical value theorem. Just as your friendly reminder, notice that nowhere in my justification did I ever mention the words lonely critical value theorem. Using those as justification will get you in hot water. All you need to do is say because it's the only critical value and it's a relative extreme, it's also the absolute extreme as well. Make sure you write down the questions that you have, the things that you didn't quite get, the things that aren't clear, and the things you want to talk about more, and we'll have a nice discussion in class. Have a good night, everybody.